Now, at this point, we could have chosen Verimax, and it would give us a Verimax solution just like SPSS. And in fact, I think this, no, it didn't come from SPSS, but it came from some other R methodological software package. We just took the instructions out and plugged them in, so it does the same thing. And again, Stevenson would not be opposed to looking at the Verimax solution, and sometimes if that looks good enough, he would accept that. He once said that he was a lazy person and would go for those kind of solutions if they were suitable. But he always reserved the right not to. And in fact, built into this program, once you have Verimax, if you don't like what you see with a Verimax solution, it then says, do you want to rotate it further? And you can then begin the judgmental rotation at that point and start rotating the Verimax factor. Or you can begin at this point by selecting option 5, which is the Q-rotate phase, in which it initially asks whether this is a continuation of some previous rotation session. If we had rotated and then, but weren't quite finished, took a break and came back, we would start here. Do you want to continue where you were? But since this is not the continuation of a previous rotation, I would say no, that it's not. And it gives the factor loadings. Now, prior to this, we haven't seen it yet, is the correlation table, and that correlation table will probably have a correlation of minus 0.13 for respondents 1 or 2, and 1 and 2, which is the ones that we just did by hand. The correlation matrix is a very dynamic kind of thing. I've only become aware of that myself fairly recently, of changing one Q-sort, for example, or adding one more Q-sort to maybe 30 Q-sorts, and seeing there be dramatic changes in the results that come out, because there's a certain dynamic that is in here amongst all of these things, and I think that is also what reminded Stevenson of quantum theory. But what, in essence, factor analysis does is it takes this correlation matrix, 6 by 6, the correlation of respondent 1, 2, and 1 with 3, and 1 with 4, and 2 with 3, and 2 with 4, and so forth, all of the individuals, and it goes through and asks, in effect, how many basically different ways were these statements organized? If everybody came to the conference for the same reasons, then they'll rank them in essentially the same way. They'll all correlate highly with one another, and they would be just one factor. And that would be demonstrated here by having all very high scores here, that is 0.5, 0.6, 0.7, 0.8. The decimals are left off here, incidentally, indicating that there was one factor. And the rest of these factors, factor 1, factor 2, factor 3, and so forth, as I indicated, only takes out 6 because there are only 6 Q-sorts. These numbers would all be very small, like 0.2, 0.10, or whatever, and there wouldn't be any more variability. But we see here the fact that the second factor has a relatively high score, 0.57, that there probably is at least 2 points of view, factor A and factor B here, and possibly a third point of view. And how many factors there are is a purely empirical thing. We may anticipate ahead of time that we expect to get this factor or that factor, but we don't know for sure until we actually get the factor analysis. So the results are indeterminate. We don't know in advance how many factors or what precisely they're going to look like until after the fact. These are the original unrotated factors, and what we're doing at this particular stage is wanting to make some sort of decision about if we want to look at the factors in a different kind of way. Now this is the tricky part. After you've done a number of these, you can start to conceiving of these factor analytic pictures in your head, and it becomes simpler. Before that, it just looks like a mass of numbers, and it's very hard to think about what it is that you're doing in a theoretical kind of way.